components sponsored by Boeing. At that point, I transitioned to industry. I worked at Rolls-Royce Corporation as a materials engineer. I realized very quickly that I wanted to look at different ways of enhancing the technology and including more modeling strategies into how we produce parts. So for that, I talked to a lot of my colleagues at Rolls-Royce and decided to go back and pursue a PhD. And I went back to U of I to pursue a PhD in mechanical engineering, and Rolls-Royce was kind enough to sponsor me on looking at modeling techniques for lifing their turbine discs. Afterwards, I thought, okay, now that I've modeled, how can I make sure these models are accurate? So I stayed on for a postdoc more on the experimental world. So what I want to emphasize here is my route was mechanical engineering to materials engineering into industry, and probably I should have another arrow into back to mechanical engineering to aero. So a lot of times when we think about making a choice about disciplines, we think once you're casted as one discipline, you stay fixed in this. But engineering as a whole is very interdisciplinary. And I really benefit from the fact that I bounce back and forth between mechanical engineering and materials engineering into aerospace, and the fact that I have both industry and academic experience. Could you go to the next slide, please? So a lot of what I work on is regarding engines. So engines, when you look at it, the gas turbine engines that really propel large aerospace crafts, they have enough power to really and we did this a lot when we started to do outreach to a lot of K through 12 schools. So they lift 100 tons airplanes to 30,000 feet in under 20 seconds. So I'm still blown away by that stat. And I think most of us as engineers or just human beings are, to make something that is capable of that feat is nothing short of remarkable. So at full speed, an engine rotates 3,300 revolutions per minute. If you were to look at the weight of a small Honda Civic, that engine can lift a Honda Civic up 7 stories and essentially throw it over a 7-story building. So that's again remarkable. And if you look at a blade that sits along a turbine disc, that blade is pulling on the turbine disc with a centrifugal force, and that's the equivalent of 13 elephants hanging off that blade. So all of these things are huge amounts of engineering feats that go into an engine. Could you go to the next slide? Now I'm going to be biased here, but when I look at a gas turbine engine with all of those feats, if we look at the main problems, we want higher temperature. And with higher temperature means better efficiency with fuel. We want reduced weight to burn less fuel, and we want faster speed. All of these things are attributed to we need better performance of our materials. So all of them are materials issues. And that's why I like my interdisciplinary background to apply materials research to aerospace components. And could you go to the next slide, please? So COVID has slowed us down a little bit, but at the same time, all the projections, and we look at these daily, says really air travel will bounce right back to the levels that it were previously. So if you're familiar with Moore's law is how computer speeds continue to increase. Akin to this would be air travel. So with air travel, every 20 years, we increase air traffic. And you can see on the right just the amount of air traffic that has increased continuously. So our goal here is to reduce carbon emissions by 75% and reduce nitrogen emissions by 90%. So we need to make the engines more efficient. And how we do this is to really operate at a higher temperature. Materials play a huge role in that, in weight reductions. And we want to introduce more materials with the ability to operate at higher temperatures. And what this is going to be related to is a 50% reduction in cost and significant reduction in development cycles, all to enable this overall goal of operating at higher temperatures. Could you go to the next slide? So at the end of the day, materials have the harshest environments. We talked about the highest operating temperatures and the highest stresses. Remember all those elephants hanging off the disc. But at the same time, we have almost zero margin for error when it comes to material failure. When a material fails, it's catastrophic because unlike a car, we have no option to really pull over to the side of the street. It usually makes front page news on the newspaper, or it will make something on CNN. Certainly, we don't want to subject the passengers to any sort of material failure. Can you go to the next slide? Oh, so with this, while material failure happens, we want to make sure that our components not only operate at a higher temperature, we reduce weight, but are safe. So because of all these reasons, these materials are critical. And that's some of the aspects that I studied, is introducing new materials into aerospace applications, making sure that our margins for safety are still sound, and that we're getting the most out of the efficiency of these aircrafts. Now, a little bit broader about the School of Aeronautical. We're a big school. We have 900 plus undergrad students. We have 600 plus graduate students that make up master's and PhD. And we are really a top school in the US, but also worldwide. So here are some statistics. So for US News and World Report, our undergrad program is ranked 5, and our grad program is ranked 6. In terms of innovation, we've been rated number 5. And from terms of aspects of investment, we're ranked number 4. We are known as the cradle of astronauts. So that's a hallmark that we take very seriously. And while it doesn't show up here, Purdue as a whole has 26 astronauts that we've sent into space. And that's soon to be a lot more than 26. Aeronautical accounts for 16 of those astronauts. Could you go to the next slide, please? So you may wonder where some of our students go to. These are numbers as of 2019, so a little bit pre-COVID. We're looking at updated numbers, but those are always slow to come in. Our job placement rate is excellent. 97% of the students have a job at the time they graduate. And as you can see, the average salary is extremely high. All the top aerospace companies, we have lots of representation in terms of our students working there. So if you look at Boeing, Lockheed, GE, Northrop Grumman, Rolls-Royce, Pratt & Whitney, we're all there. As well, we have more employees at SpaceX, Blue Origin, and even GE and Rolls-Royce than any other school in the world. If you start to look at space applications like NASA, SpaceX, Blue Origin, a lot of our students, actually, we make up most of the students at Blue Origin as well. Could you go to the next slide, please? So the common theme with Aeronautical is we deal with aircrafts and spacecrafts, but the disciplines are very, very different across all aspects of engineering and science. We look at aerodynamics, how the flow of air goes around the material, or well, around our craft. We look at astrodynamics that looks at space applications, but we also look at orbital mechanics. We look at propulsion. So from a aircraft or even a spacecraft, how do we get this into flight? Structures and materials to make sure we're sound structurally and we can withstand the service loads. Autonomy and control to make sure that now they say aircraft, spacecraft are like a flying computer. So how do we operate all of these controls? And then aerospace design systems. So the fact that the complexity has gone up so much over time, how do we get the whole product lifecycle into flight and maintain it throughout its service life? Could you go to the next slide? So this is this a video? I'm sorry, I don't quite recall. It might not be. But one thing that we want to really stress in Aero and Astra is just the aspect of student experience. So this is Aero 418, which is a class that seniors sign up for. It's a zero gravity class. So during this class, students have the ability to design an experiment that's going to first be conducted without gravity. And so there's test facilities to do that on ground. And then out of those student facilities or student experiments, a few are tested and actually flown up to the space station. And those experiments are carried out on the space station. Another type of student experience, and I'm just going to select one more. And could you go to the next slide? And this is a video, and hopefully this will play on. Great. So this is a senior design project, and this was taken from fall 2018, where these students made a unmanned air vehicle. So you can see the vertical takeoff of this unmanned air vehicle and the flight of this airman vehicle. So with this, they're graded on many different things, but the controlled immediate takeoff and then the transition of that at least vertical takeoff to horizontal flight. So that's the majority of what I wanted to talk about with Aero and Astra. Also, I am a courtesy appointment in materials engineering. With materials engineering, Brandon's going to be talking about this later. I can also answer questions about materials engineering. Materials engineering, we look at processing of materials, all materials, and if you think about the wide variety of materials. And our materials engineering program is excellent in getting hands-on experience for students. And with those hands-on experience for students, in terms of taking that forward to make sure that all of our students know how to make and test materials of all sorts going into their professional careers. So I'm happy to take any questions that you guys might have.
I have a quick question.
Yeah, please.
So for like a student in aerospace engineering, what's it like? Is there still like interdisciplinary courses that you can take and fit into your schedule, or is it pretty jam-packed with like engineering courses?
Yeah, so we do have a core level of classes, but with that we have both engineering classes. So we split these up into major and minor elective courses, and also even interdisciplinary outside of engineering courses, more of your humanities courses that you get to select. So there is a certain amount of separating what is your core that makes up an Aero and Astro curriculum, but also what are the courses that interest you, and pursuing those courses that interest you, so you have the ability to customize your own schedule.
Thank you.
Sure.
That's good. Any other questions? Thank you so much.
Okay,
Thank
thanks,
you.
everybody. And if anybody has questions, feel free to email me. You're in good hands with both Derek and all the student representatives.
Yes, sir, if you would put your email in the chat,
Sure.
that might be helpful to some students. And then you just never know, as we continue this conversation, there may be other questions that you might be able to shed light shed light on. So we're going to move to student perspectives. And so Hannah Pike is coming at this time. She is a sophomore and she's an Aero. So now let's look at it from a student perspective.
Okay, hi, I'm Hannah. As I said earlier, I'm a sophomore in Aeronautical and Astronautical Engineering. So I guess I'll just go through this PowerPoint and then sort of go in a little more detail on some of my bullets here. So why did I pick Aeronautical Engineering? I guess I'll go over that first. So I always have really enjoyed math and science, and I really had a interest in space and aircraft, so that's why I picked this major. It's also a very innovative field, and it's always changing, and there's always more opportunities for innovation and for growth, and so it's just a really great field to be in. And I specifically picked Purdue because they have an amazing program for it. They are ranked 5th nationally, and they have a really great staff and many opportunities to make you do your best, to help you to do your best. If there's one thing I really want to emphasize is that there are just so many opportunities here to help you if you have questions and to reach out and to meet people in your major. One of them being minority engineering. There's also things called supplemental instruction where there's separate teachers who are also students who took these classes who can help you out. Your professors are very helpful. You can email them, ask them questions. They have office hours. There's TAs who have office hours. So there's just many, many, many opportunities to do your best. In terms of professional experience, so this is my first year in aerospace. I was a first year engineering student last year. And so I haven't really had much professional experience with aerospace. I will say that going from first year engineering to aerospace, the classes that you will take in first year engineering are very helpful for aerospace, specifically math, really math and physics. Math and physics are very helpful. And a lot of people want to do aerospace. It is a competitive major, but it's not scary. It is challenging, but as I said, there's so many opportunities that can make it not challenging. And then, so my career goals for aerospace, I'm hoping to complete my bachelor's degree, and then I want to go on to get a master's degree in aerospace and nuclear engineering. I'm currently getting a minor in nuclear engineering, and I'm really interested in doing nuclear propulsion. So that's my plan. Yeah. So if you have any questions, you can ask, or I guess I can touch on the question that you asked earlier about classes. Yeah, so aerospace, we have a set list of classes that we have to take, but when you pick out your specialization towards the end, you kind of have more freedom about what you can take. And so in the beginning, it's more you take the aerospace classes that are like the basis of aerospace, and then you can go on to take classes more specific to what interests you, whether that be the structure of a plane or the materials or propulsion. So you can do that. And then we also take what are called general electives, and those are kind of like, I don't want to say fun classes on the side because some of them are a bit of work, but they're classes that you can take that kind of spark your interest outside of engineering. So like I'm taking a political science class as a general elective class. So you can take other unrelated to engineering classes that will count and might also spark your interest. So yeah. So if you have any other questions, feel free to ask.
Thank you so much, Hannah. Now we're moving on to materials engineering. And for this conversation, We're going to Brandon Wells, who will introduce himself and then go on to talk to you more about this major.
Hi, and thank you for your introduction, Derek. And like I think Professor Sanjit said, a lot of problems that engineers face are at the root materials problems. So I really like when he brought that up. And if I had to explain what materials engineering is, it really kind of starts with the question of, you have this engineering problem, you need a turbine that can, lift the Honda Civic above a 7-story building. But then how do you make that? I mean, you have all the mechanical parts that go into that, but then starting with, you're going to build a part like a turbine blade. What properties you need from that turbine blade to get it to perform at the level that you need, and then what is the process like to make that? You don't just shape it out of some clay and then put it in a kiln, and then understanding really the real materials part is then understanding how the different processing steps affect kind of a structure within the material, because at the root you have a lot of different materials, but then how the atoms bond and how the physics, I guess, of how the material holds itself together is what determines its properties. So we specialize in understanding what the differences are in that structure. And then if you have a specific application, how to get those kinds of properties that you want. And then one of the best parts that I like about materials is then we understand how do we make it better. There's a lot of problems now where we use certain things or we use certain materials, but then it doesn't completely solve the problem, or the situation may have changed and now we need to modify it to be more environmentally friendly or to work at higher temperatures or just to cost less. And then all of those things go into what a materials engineer does. One thing that I really like about the materials engineering program is a lot of our classes are hands-on. Professor Sanjit said that as well. Some of my favorite ones are our lab classes. And some of those, we have like a materials processing lab, a characterization lab, and then a senior design project. And in processing, we kind of, we say, all right, you're making a coin, right? What material do you start with to make a coin? How do you go from kind of a block of metal to, a nice, shiny coin that's a specific size and is a regular shape? And then how do you be sure it works in the application that you want? So you don't want it to bend in your pocket, but you also want it to, be easy to shape. So there's a lot of different things you can do in your actual classes. But then when it comes to professional experience, I've worked in a range of industries, and that's one of the other really big benefits that I like about materials engineering. Since it is kind of a more fundamental science, you can apply it in a lot of different ways. So I did work in the aerospace industry starting out, and like Professor Sands said as well, like you're trying to reduce the weight of your engine. So one of the parts that I worked on was a ceramic matrix composite, but it's instead of kind of a traditional metal material, it's kind of a bunch of different layers of ceramic material with some different fibers in between. And that allows you to get up to much higher temperatures than metal. So it lets you run the engine hotter, which is more efficient, but then also weighs a lot less. So then after that, I went on to work in transportation safety, believe it or not. So that's pavement markings. When you're on the road and at night, it's raining, how do you know if you're in the right lane or not? And staying safe on the road. So my specialty, well, my job for that was really just understanding what are the optical properties that you want to be able to see the road markings well, but then also how good do they have to be visible by like autonomous vehicles. So say you have a self-driving car, you may be able to see the lines, but can the computer see? And then also I've been doing some internships also at a national lab, and that application is much more environmental focused. And our focus for that project is how do we absorb CO2 from the environment. I mean, there's a few different ways that people can do it now, but at the scale that it's at, it's not really feasible for like, an industrial scale. So I'm researching different methods of how do we make this better? How do we make it more efficient? And this is all within the realm of materials engineering. So there's a lot of different directions you can go. I've been talking for a minute, but if there are any questions about materials engineering, I can go into more detail about some of the stuff that I did, or more about what the major is like at Purdue. And if you're not interested in materials engineering, I can try to convince you otherwise. But really though, in all honesty, even if you're not in materials engineering, a lot of people do materials work. So like Professor Sanjit said, he does some material stuff. I know a lot of friends in mechanical engineering and civil engineering who at their root are doing materials things. It just depends on what side of the problem do you want to stand on. Do you want to be building the bridge or do you want to be picking the concrete,
Exactly.
That's all I got.
That's good. Good.
Wait, quick.
Go ahead. Go ahead. I see there's a question.
Yeah, so I was just wondering, like, is there an advantage to going in as a more like specific major, such as like astronautics or aeronautics, versus more like a principal science, like you were saying, with materials and material engineering?
I'd say it depends on how you learn and what you like to do. For me, what got me into materials engineering was looking around at the different things we have and like, why does like some glass shatter, but then your windshield kind of has that kind of, you know, spider web effect? Like, what makes that work differently? And that's what was really made me really interested. And then ultimately, too, I guess if you're really focused on like an aerospace industry, you'll learn a lot more aerospace specific skills in aerospace. For me, the industry is less of a pull for me and more so just understanding the why behind it work, how it works. So then I can move into a different industry if I want to. And actually right now I'm hoping to move into agricultural research. I'm really interested in how we grow food, how do we store it, food
Wow.
packaging stuff. So I can now take what I've learned in completely unrelated things to food and agriculture and now bring that over. So it really depends on when you're learning what are the things that interest you most. But even once you get to the professional world, while you may have a specific major, it's really just based on what you decide to go into. What a lot of jobs, you'll have people working in something completely different from what they did their major in. So it's not the end all be all.
Thank you. That makes a lot of sense.
Great question. And there's so much overlap between engineering disciplines. So, you know, and there's quite a number of students who start off with one major in mind and then they switch later. Brandon is a graduate student in,
Forgot to mention that.
yeah, that's okay. Well, tell them, I'll let you tell them. I won't steal your thunder.
Yeah, so I guess I started out in undergrad doing research for a group here, and our project was kind of agriculturally focused, but more on the processing side of materials engineering. So we want to make these really small capsules, think like boba, but then you fill it with different things to give it different properties and use it in different applications. So that turned into my master's project, and now we're using that and applying it to concrete. So how do you kind of help regulate the temperature of concrete? And I'll be doing research with that for the next year or so. But I really enjoy, I guess, the opportunity to go deeper into research. Again, it's about understanding the why, and then if you want to take that knowledge and apply it somewhere else, how do you do that? What kind of tests you need to conduct, and how do you document it in a way that somebody else can then take that information and do something even cooler with it that you didn't even think of.
Thank you so much. And in addition to Brandon today, and probably not so much speaking, but our graduate assistant, Vivek, is also present today. He's finishing up his PhD. If you would at least introduce yourself and tell us, because you're about to finish your degree.
Okay, so my name is Vivek Muralidharan, and I'm a PhD candidate in aerospace engineering as well. My field of research is in orbit mechanics. So field, like, we work on designing transfers from like Earth to the moon, like to the Mars, and like different regions in space. And how do we not just designing the trajectories in space, but how do you maintain the spacecrafts in the trajectories that you envisioned, or how do you make sure that the spacecraft goes along the trajectory that you designed? And different exploration, like, how do you understand the gravity of different celestial bodies? What are the other forces that are acting in space? Like, it could be solar radiation pressure and things like that. So I work on outer space, all these mission scenarios. Like, a lot of projects that we work on are based on NASA's projects. It could be in the cislunar space, or it could be like even deep space missions. Yeah, that's a brief idea of like what my area of focus is.
Excellent. Thank you so much for that. Now we're moving on to nuclear engineering. And Jonathan's going to tell you about himself and also show you why you ought to consider nuclear engineering.
Yeah, thank you so much for the introduction. So, as I said before, I am a senior in nuclear engineering, and I guess it says down at the bottom, I plan on going to grad school and getting a PhD in nuclear engineering. So that's the current plan. But well, I guess I should start off with defining like what is nuclear engineering? I think in the most generic terms you can use, you can say it's applying nuclear physics for practical purposes, right? So I guess what does that actually mean? There's a variety of different fields that you could go into that relate to that. But something we talk about a lot is like the use of radiation and radioactive materials, how that interacts with matter. How can you use that to our advantage, right? Things like plasma physics. How can we make a fusion reactor, right? We talk about that a lot. There's also nuclear fission. So you might be familiar with nuclear power plants. You might know maybe a little bit about how they work. You use particular kinds of nuclear materials, and you regulate a fission chain reaction. And so you can get a ton of energy out of a relatively small mass of material. But I also want to be careful because I think a lot of people that have heard of nuclear engineering, the only thing they know about it is nuclear power, right? Homer Simpson. Like, I feel like I've talked to a lot of students. They're like, oh yeah, nuclear kind of sounded cool. I think, nuclear technology is cool, but I felt like if I went into nuclear engineering, I would just have to go operate a nuclear power plant and sit, in a windowless room for 10 hours a day. And that's not necessarily true at all. Like, if you're interested in nuclear power, that's like 100% an option you can go down. But personally for me, I was not at all, like when I heard about nuclear engineering. And in fact, I didn't go into school thinking that's what I wanted to do. So if you're not already aware, if you're a freshman in engineering at Purdue, you're in first year engineering, so you don't get assigned your major yet. And once you go through first year engineering, you end up applying to your major, and depending on your GPA, I think it's mostly GPA that they make the decision based off of. But if you get a high enough GPA, you can get to the majors that you want. But the point is, you kind of get the option to explore several of the different engineering majors. And for me, I actually planned on going to aerospace. I was like, I think it'd be really cool to work on rockets and send people to Mars. Like, I want to do something meaningful and impactful. And I actually took a class with a nuclear engineering faculty here the fall of my freshman year, and I learned about nuclear nonproliferation. That was what the class was on. And it was really fascinating. And what I found was that nuclear engineering, and specifically in the nonproliferation area, offered a really meaningful and impactful career where you could work on technical or policy issues, and you could have a real impact, right? You can get some really cool jobs doing really cool hands-on work or really cool policy work, right? Anyway, that's basically how I found nuclear engineering. And you can see, I can talk a little bit about my professional experience. I've had a few internships, two here listed with the U.S. Department of State and the Nuclear Regulatory Commission. And Department of State was really cool. Unfortunately, they're not a paid internship program because it wasn't actually an engineering internship position. It was a policy internship position. But the only reason I was able to get it, as a sophomore, was because I had the technical background, right? That gave me a little bit of credibility, like, all right, this kid's probably smart enough where, we can hand him some stuff to do and he can figure out how to do it. And so, there are a lot of opportunities for more policy kind of positions too, if you're interested in something like that. Nuclear Regulatory Commission, again, another government agency, but a little bit more technical work, but that was, also something very interesting. I was doing, emergency preparedness for nuclear power plants. So, basically learning about how do we prepare in the event a nuclear power plant accident happens, like 3 Mile Island or Chernobyl or Fukushima, right? What do you do if something goes wrong? Yeah. And how do you make sure people are protected? And how do you know what kind of risk is there? So all that kind of stuff. Anyways, so I've rambled a little bit about those experiences. I'm happy to answer more questions about any of that. But I guess the key takeaway that I think is important to have with nuclear engineering that a lot of people don't realize is that there's a huge array of things you can do that aren't just nuclear power. You can do the nonproliferation or nuclear security, working in, how do we protect against nuclear weapons? How do we protect nuclear material from bad guys that want to get at it? You can work in medical imaging, creating things like CT CAT scans, developing isotopes that are very, very useful for, radiotherapies like technetium-99, extremely useful in imaging and therapy. And then, of course, there's things like naval propulsion. I didn't mention it, but didn't mention it before. But there's also space propulsion, which is something Hannah talked about. She's interested in going into. So you can actually, to get into space propulsion, you can go the aerospace route. You can also go the nuclear route, depending on what some of your other background interests are in. So, yeah, I'm happy to take any questions. I could talk about it all day. So,
Excellent. Any questions?
Yeah, I have a question.
yeah.
So you talked about how you can have the different like sides of nuclear engineering between like policy and a more technical career. Once you choose one of those sides, is it easy to switch back over, or is it like kind of stuck on one side or the other?
Yeah, no, that's a really good question. I guess the answer is it kind of depends. So for the most part, I would say if you are, and from the people that I've talked to in policy positions, right? I talked to people for career advice when I was in my internships, and basically what I heard across the board is you should keep, if you're studying engineering, you should keep studying engineering. If you get a degree in, like for me in nuclear engineering, like if you get your degree, you can work in these policy positions. And it's going to give you, especially if you show interest in those policy areas. For me, I'm getting a minor in political science, and I'm having some of these professional experiences that are policy oriented. I can get those policy positions no problem. Same as somebody with if I get a PhD in nuclear engineering and it's something related to nuclear nonproliferation or nuclear security or counterterrorism, something like that. Somebody that goes and gets a master's of public policy, I'm gonna basically look the same in terms of eligibility for those positions. But I'm also going to be able, if I want to say, hey, look, I really like doing technical research. I want to go work in a national lab. I want to develop the newest detector that's going to let us do X, Y, Z, right? I can do that as well. So I know lots of people that have gone and worked for technical, had technical positions. They've gone to national labs, and then they've decided, hey, I'm going to turn around and work in Washington, D.C. doing something policy oriented. That happens all the time, and it does go the other way too. One of my professors here, actually, he is leaving at the end of this year, but he's been a very close mentor for me. And he started out, he got his PhD in nuclear engineering here at Purdue, and then he went on to a national lab. He was doing technical work, and then he decided he wanted to sort of change a little bit that direction. He ended up going and doing policy work for the Department of Energy, and then he went and became a professor, and he was doing technical research again. And now he's kind of bouncing between he's sort of in the middle of that technical policy area. Is that a nexus kind of, which is I think a unique opportunity that nuclear engineers get to have a lot. That not to say you can't find it in other engineering majors, you can, but nuclear engineering really lets you carve out the path that you want for yourself.
That's good.
Hopefully that answered the question. Yeah.
Yeah, thank you. Appreciate it.
Good. And I think, as we wrap things up, I'd like to ask just some general things, because we're speaking with prospective students. We're thinking about colleges and making decisions. And I think it's not every day that you have a faculty around. So I would like to ask Dr. Sanjit a question and address him and the students with just a few questions before we go today. And so I'd ask, from a faculty perspective, what do you see, or what do you look for in a student? How would you describe, because we're talking about the aeronautical student in aeronautical, astronautical engineering, what are the types of qualities that you see in a student from the get-go to tell you that this is the type of student that may do well? What is the type of mindset that a student has to have? And this may be true across the board with any subject or discipline, but we just like to hear your opinion on that. He may have said, Dr. Sanjit. So I'm gonna turn it around, flip it around. If he comes back, we can. Let me just hear from those here in the room. Well, I'm not in the room, but in the virtual room. What do you guys see as a successful student? What has it taken from you? I mean, think back, you were a high school freshman at one time, looking at a Purdue or whatever university. And what did it take for you? What kind of mindset did it require for you to become a
I know
successful?
for I know for me, it's definitely not walking into the room knowing everything, or even thinking you know everything. My first year engineering experience was pretty rough. I didn't know anything about computer programming, had not done anything with robotics, and that was kind of the crux of what my first year experience, like what the projects and stuff were like. And it felt a little discouraging at first, but then as I got later into the different classes and started looking back on it, it's much more how you approach those situations where you don't know anything. And I think I really enjoy those situations now because that's where you learn the most. If you walk into a spot and you might know half the things, you might, approach it slightly differently. You may not try to absorb as much as you can, but really walking into new scenarios, how do you respond to that, and try to be at least persistent in learning something. It doesn't have to be everything, but how you try to approach that problem is really important.
Mm. Others, that's good.
I would say for me, something to help me be successful was having a willingness to ask for help and to understand when you need to ask for help.
Mm.
Along with Brandon, I'm not really a coder. And so I understood that I did not know how to code. So I had to reach out and go get help. I had to talk to the TAs. I went to supplemental instruction, talk to the professors. So I'd say just I know sometimes it can be a little awkward. If you're like the quiet kid in the back of the classroom, you never want to raise your hand. You kind of have to step outside of your comfort zone and
Mm-hmm.
raise your hand. Even like if you just meet with, like you could find a study group, for example. Study groups are great because some people may know more than others and you can help each other out. So just kind of stepping out of your comfort zone and knowing when and how to ask for help.
Wow, I love it. I love it. Your answers were great. Each one of you are covering a different aspect. We're not going to leave out Jonathan.
No, definitely. And I think actually I was gonna even talk about what Hannah had mentioned with knowing what your limits are and knowing when to ask for help. I think one of the big things, and I neglected to mention this before, but something that was really important for me, especially when I was a first year engineering student, was keeping an open mind, right? Because like I kind of went in with that preset, thinking like, oh, I'm going to be an aerospace engineer. I'm going to be an aerospace engineer. And I think if I would have just, kind of stayed in that gridlocked mindset, I wouldn't have had as enjoyable of an experience just because it wasn't right for me, right? Not to say I wouldn't have enjoyed it. I think I probably would have. But I think to find the right experience for you, I think keeping an open mind is very important. Exploring all of your options, asking people, as many people as you can, and trying to use others' experience and others' knowledge and wisdom to your advantage, right? Because that's one of the great things about being at a university like Purdue. It's a well-regarded university. It's got a lot of talent and a lot of knowledge here in our faculty and our staff and our graduate students, certainly. And trying to talk to as many of them as possible, learning from them, getting advice from them, I think is super important. I think resiliency is also important in making sure you keep your head up, because you're probably going to encounter a lot of challenges. I know I did early on in my undergrad experience, and learning how to come back from failure, learning how to fail with grace and ask for help when you need it is definitely
Wow.
important skills, and they're going to be good life skills for sure.
Wow, excellent. You guys, I see you guys are good advice givers. So we're going to, because I think there would be students, of course, we will be broadcasting this on the MEP YouTube channel, where we'll have dozens and dozens of students tuning in to watch these videos at their convenience. The last two questions are just advice you would give. Number one, on selecting a major, because some people say, oh, I want to major in such and such. I know what I want to do. Of course, we see a lot of students change after they arrive in college. What advice would you give about selecting a major and plotting your career as it relates to your career?
I guess I'd say something similar to what I said in my previous thing is just you can select the major, but also know that what you do for work goes beyond that. And I guess when selecting a major, do your best to talk to older students in that field because they can give you the lowdown about how that program works at that school. You can find a lot of information online about what a major does, but then also knowing how the program works at that school can really be beneficial, whether that's what classes you can take or what professors you really want to try to talk to or just best strategies for working through that. But then also, I didn't know about how to find my interest in agricultural engineering and stuff like that until later on. And that kind of now shapes what I want to do with my career now. So still trying to keep an open mind and realize that, wow, this is your major now. After Purdue, you're going to be doing some work, and it can be really in a lot of different places because Purdue gives you access to that. So then if you need to take inspiration from outside of your major to pick what you want to do, follow that, pursue that. And more often than not, there's somebody also around Purdue that can help you find out how to make those two things meet. It may not seem like that initially, but you can definitely find a way.
Wow, that's great. Advice on selecting a major as you plot out your career trajectory.
One thing I would say for selecting a major is one route you could use to select a major is to pick a topic that you're really interested in, or like a career, just a topic you really want to know more about. And then you can start to look at what different types of majors can go along with that and what part of it you want to be a part of. Like, for example, I want to do nuclear propulsion, so I started with that idea, and then I sort of went from there. Another thing, this will be a Purdue-related tangent, but Purdue, when you're in first year engineering, they do this pick your engineering major thing, and you watch all these videos, and you go to discussions about each major or the ones you're interested in. And I know for me, I was really torn between aerospace and nuclear. And I actually watched the presentations, and I found out the people who were speaking. I wrote down their emails, and I met up with a couple of them just to figure out which one I wanted to do a lot more for. And I ended up still being torn. And so what I did was I picked aerospace and then picked nuclear as a minor because Purdue doesn't have an aerospace minor. It's not a thing. And so I tried to get the best of both worlds the best I could.
Yeah, no, I think what Hannah suggested is actually really fantastic. I was going to say something very similar to that. And my other piece of advice on that is to, when you're finding the areas that you're passionate about, like the fields that you want to work in, the topical areas you want to work on, right? Approach it with sort of like a good mixture of pragmatism and, excitement about a particular topic, right? And I said pragmatism and passion would be the good mixture to have, because you want to find things that you're like, yes, I want to work on this. This is a really cool challenge. I'm doing something really important. I'm doing something I really care about, something that you could see yourself spending your career on. And then you also want to say, okay, are there enough opportunities in this field? Like, okay, if there aren't that many, what happens if I can't find the position that I'm looking for? Is there a good contingency for this major that I'm looking into? What are my routes I can go to get there, and which offer me the greatest options of things that I'm interested in doing? I think those are all good things to be thinking about.
And lastly, thank you so much. That's great. And our last piece of advice is, how do you select a college? I'm looking at 3 different schools. I've been admitted to 5 different schools. I've narrowed it down to 3. But, any advice on choosing a post-secondary institution?
Go ahead,
Anna. I saw we both clicked unmute at the exact same time. So my advice would probably be do your research and look at what school is the best for what you want to do. Also, if you are a little wishy-washy about what major you want, you can, or what engineering, you should look at the schools that offer you a period of time to explore them. I know that when I was picking a college, I was in between University of Michigan and Purdue. And I was a little wishy-washy, again, between aerospace and nuclear. And at Purdue, you got a year to sort of explore both of them. Well, at U of M, it was you pick what you pick. That's it. So I would say definitely, if you know what you want, great, but there's always other opportunities out there. So keep that in mind and just figure out what college would be the best experience for you. Yeah, and you can also look at student organizations and other things you'd be interested in. I know for me, a big part of coming to Purdue was the marching band. Purdue has a great marching band, so that was something that drew me here. So yeah, just take a look at what colleges have the best programs for you on what you want to do, and what colleges have things that will interest you the most.
Thank you. Very good. Very good. And I want to hear from both of you before we close out.
Yeah. For me, I would say is look at this is, I guess, also depending on your major, but also just depending on the college. But is the program growing? Like, what direction is the program going? I know when I was applying to places, there were two programs that were like about even on like the world rankings, I guess, but also about size as well. But since I got to Purdue, the materials engineering department has grown a lot. There's a lot of momentum behind bringing in new students and what kinds of new things they're offering, and even as a school, Purdue is now offering like vertically integrated projects and like design projects that are interdisciplinary, and a lot of different opportunities that you may not see or may not be there now, but if you can watch how the university has grown over time, you might be able to see a little bit more about where they're going to go, because the school will change while you're there. That's just what's going to happen. And then also what Hannah said is what else can you do outside of your major? I mean, I'm in the jazz bands, and that is, I think, a unique thing that Purdue offers is you have a lot of music opportunities, even though we're not a music school. So I was still able to develop and grow my music ability while also studying really hard in engineering stuff.
Thank you.
Yeah, I think Hannah and Brandon both gave really great advice. And on Hannah's point of picking a engineering program that'll let you have a period of time where you get to decide which particular major, even if you're like dead set, like, yeah, I know I want to do mechanical engineering. Don't let Purdue's first year engineering program be a detractor necessarily, because I went in dead set, like I knew I was going to do aerospace engineering. And then, like, lo and behold, 12 weeks later, I was like, okay, now I know I'm doing something totally different. So, yeah, I would say, again, I guess it's on that keep an open mind point. For me, I can't talk too much about my decision-making process other than, for me, it was close enough to home. And it was something that my older brother went here. And so I knew a lot about the school. I knew about the student life here. I knew I was going to enjoy it. So I'd say, finding a place where you can, the location is something that you can live there for 4 years and be happy, right? Somewhere there's going to be good extracurriculars or good, a social or even a weather climate that you're going to, like, right? That you're going to be able to put up with, and it's going to keep you happy, right? Because if you're doing something hard, like engineering, almost anywhere is going to be tough. So making sure that you can keep a good work-life balance as much as possible, and good mental health is going to be really, really helpful as you go through a hard academic program.
Thank you. Thank you. You guys, we want to thank Dr. Sanjit. We want to thank our fine students. You guys are just simply marvelous, and you've offered so much great advice and information. Oh, and I meant to give kudos to Brandon, who was a speaker at commencement this past December. Brandon, how was that experience being there's a title for was it called the responder?
Student responder.
You were the student responder, and when you got to do that, were you the student who spoke at the commencement? How did that work? Because I haven't been to commencement in a few years.
I guess the way that it works is they just have different graduation ceremonies, and depending on whether it's spring, fall, or winter, they'll group different colleges together. So when I did, I think they grouped 4 different colleges together. They had 2 different student responders, one for each. But it was really interesting experience. I didn't at any point of me being at Purdue, I didn't expect to do something like that. But it was a really great way to reflect, I guess, on my time here. And what mattered, I guess, in those past 4 years, and the people that I met and what I learned, and then just what I wanted to tell my graduating class. It's not often you get to kind of speak to everybody at once, but it was a really great opportunity.
And to our prospective students, there might be someone out there that you might be so lucky. So before we go tonight, we just do want to remind you of our session tomorrow night on college affordability. You've probably already read through it and you've received our email announcements. We're closing out for now. Feel free to join in on any of our sessions. If you have any questions, you can contact me, Derek Williams, at dwilliams@purdue.edu. I'd say so long for tonight, and everyone have a good evening. Boiler up.